Hi, my name is Prince and we'll discuss the effect of rotation of Earth on the apparent weight of an object. Okay, so let us say that this is the Earth over here. This is the Earth over here, and we know that we can assume that this is an axis of rotation about the which Earth is rotating with some angular speed omega. Okay, so what is omega here? This is the angular speed of Earth. Okay, let's assume that omega is the angular speed of Earth. Now this is the equatorial line or the equator over here. Now let us say that you consider an object placed somewhat like this here. Let's say this is the object here. This is the object. And we define something called the latitude. Now what is latitude? Carefully understand. Latitude, it's the angle made with the equatorial plane. With the equatorial plane. Okay. So in other words, if you consider this object over here, this is kept at an angle, you can say from the equator, the angle made by this object is the latitude. Let's denote it by the letter phi. So this angle over here is phi. So we'll consider an object placed at a certain location on Earth whose latitude angle or angle made by the object with the equatorial plane is phi. Let us say that. Obviously, this is the center of the Earth and we can say that this distance is going to be radius of the Earth. So let radius be r. Let radius be r. Let radius be r of Earth. Okay, could be any planet. Now, let us consider the forces that will be acting on this object. Okay, so I'll be considering what all forces are acting on this body. Assume that the mass of this body is m, right? Now, as you can understand, obviously there will be a weight acting, right? And what will be the direction of weight? The direction of weight will be this way, yes or no? Towards the center of the Earth. Remember that the weight is always going to act towards the center of the Earth. And how much is the weight? Weight is equals to mg, right? Mass into acceleration due to gravity. Now, apart from that, obviously there is a normal reaction in this direction. So there is n, right, perpendicular to the contact surface. Okay, remember normal reaction is perpendicular to the contact surface. Now apart from these two forces, you will also have a centrifugal force. Why we will have a centrifugal force? Because the Earth is rotating, right? So you can imagine that this block kept here, it is moving in a circular path, right? You can imagine this is moving in a circular path, and obviously the circular path's radius is not going to be the radius of Earth, it's going to be something else. Carefully see. If this length you assume as r, okay, then what is this length from here to here? This is going to be, if you pay attention, this length, let us call it r. R is going to be equal to r cos of phi. From the triangle you can see. Okay, so because it is moving in a circular path, we are saying that the mass moves in a circle of radius r. Okay, now obviously r and r relationship we know now here. From the figure you can see that r should be equal to r cos of phi. So due to this rotation, due to this moving in a circular path, what will happen? There will be an extra force acting. What will be that? The centrifugal force, right? How much is the centrifugal force? M omega square times r. We can say centrifugal force is m omega square r. Now due to this centrifugal force, what will happen is that the normal reaction is going to change. Okay, first of all you can see that if this angle is phi, definitely the angle between normal reaction and m omega square is also phi. So I'm drawing this over again here. So you have normal reaction pointing like this, you have weight vector pointing like this, and you have m omega square r like this, and this angle is also phi, remember that. So if the body is at rest, if it is at equilibrium, we can say at equilibrium equilibrium. Consider the component of this m omega square along this direction. So you will have n plus m omega square r cos phi. Now remember, r is what? That is already r cos phi. So you will have one more cos of phi here. Yes or no? That should be balanced by the weight. That should be balanced by the weight. Now this normal reaction that we are getting, this normal reaction is itself the experience of weight, right? When you're standing on a level ground, everything is at rest, there is no rotation whatsoever. Here your weight is balanced by the normal reaction. Because you are feeling the normal reaction, that is why we say that since you are at rest, we say that n equals to mg here, right? Imagine yourself moving in a lift. If you are in a lift, what happens? You experience a different normal reaction here. If you consider the free body diagram here, you have the weight acting this way, you have normal reaction acting this way, and n minus mg is equal to ma. And you can see that normal reaction comes out to be m times of g plus a. What does this physically mean? It means that as you are moving in the lift, what is happening? You are experiencing a different normal reaction. So you feel a little heavier if the lift is accelerating upwards. So we can say that this normal reaction itself gives you the experience of weight here. So let's just make it m times some other acceleration due to gravity, let's say g dash. Okay. So that is your apparent acceleration due to gravity, you can say. And from here you find that this is equal to mg minus m omega square r cos square of phi. Now obviously m gets cancelled, and you find that g dash is g minus omega square r cos square of phi. Now this relationship that we just found, okay, this g dash is called apparent acceleration due to gravity. Apparent acceleration due to gravity. That means this is the apparent weight that you will feel. Your weight will be mg dash. Okay. So for example, if you are at the pole, what will happen at the pole? At pole, if you consider the situation, let's just consider the situation at the pole at the equator. At pole, what will happen? At pole, what is the value of phi? You can see the value of phi becomes 90 degrees. Yes or no? The object is kept here. So at pole phi will be 90. In that case, g dash will become g minus omega square cos 90. Cos 90 is 0. Cos square 90 is 0. So g dash will be g. That means 9.8 meter per second square. Whereas at equator, what will this be? This will phi will become 0. So this will become g minus omega square r. Right? At equator, you can say that g dash will be g minus omega square r. That means what? That means that at the equator, the body's apparent weight will be least, and at the pole, the body's apparent weight will be maximum. Okay. So this is the concept of apparent weight due to the rotation of Earth. Thanks a lot.